Question number 21. Which compounds would produce two different carboxylic acid when heat treated with hot concentrated acidified? Two different carboxylic acids when heated with hot concentrated acidified potassium manganate. Two different carboxylic acids should be formed. In option A, so this double bond is oxidized and has CH3CO2H, and this carbon uh, ketone is formed over here. So not this is incorrect. And in option B, CH3CO2H, and this compound CHO2C, this is, and this two different carboxylic acid is formed in B, so B must be correct. And let's see, check. 1 2, this cyclic structure is open. 1 2 3 4 5 6, double bond OH, double bond OH, and double bond OH. So this is also incorrect. Over here same functional group is formed, double bond OH, same carboxylic acid is formed, OH. So this is also incorrect. Question number 22. Which compounds could show both cis-trans and optical isomerism? For cis-trans isomerism, there are two conditions, that it contains carbon to carbon double bond, and each double bonded carbon atoms is attached with two different groups, X and Y, X and Y, two different groups. And for optical isomerism, the compounds containing carbon which is bonded with four different groups, now let's check. This is incorrect because this double bonded carbon is attached with two same group, bromine and bromine. This must be correct because each double bonded carbon is attached with two different groups. Br is different, BRH is different, and this group is different, and it must have optical isomers. So this carbon is surrounded by four different groups. That is, 1, bromine is different, H is different, chlorine is different, this whole group is different. So B option must be correct. And now let's see, check C. This carbon is correct because it is bonded with two different groups, H and two different groups. Cis and trans isomers is there, but this carbon should be chiral, but this is attached with two same group. So optical, in this compound, no carbon atom is chiral carbon. So this is also incorrect. So D option is also incorrect because this carbon is bonded with same atom or element, so this is also incorrect. So B option is correct. Limonene is a hydrocarbon found in rind of citrus fruit. What is the molecular formula of limonene? So just calculate the number of carbon CH3, and this is CH2, this is CH2, this is C123CH, this is CH3, this is CH2, and this is C, and this is CH, because 1 2 3 4. So let's check number of carbon atom. 1 2 3 4 5. 1 carbon, 2 carbon, 3 4 5 6 7 8 9 and 10. So C10. Let's check number of hydrogen atom. Over here hydrogen is 3, this hydrogen plus 1, this hydrogen plus 2, this hydrogen plus 2, this hydrogen plus 3, no hydrogen atom, this hydrogen plus 1, this hydrogen plus 2, and this is also plus 2, and this CH3 contains 3 hydrogen atom. So 3 plus 1 4, 2 4 2 6 8 11 12 and 15 17. 3 1 or 2 3 1 is 4, 4 or 2 6 8 11 12 1 1 2 3 4 5 6 7 8. So 2 carbon, 3 4 or 2 6 7. This is 7. This is 3 hydrogen atom. This one is double check. Let's double check. This is 3 hydrogen atom. This is 1 hydrogen atom. This is 2 hydrogen atom. This is 2 hydrogen atom. This is 3 hydrogen atom, 1 hydrogen atom, 2 hydrogen atom, and 2. 2 and 2 4, 5 or 3 8, 8 or 2 10, 10 or 2 12, 12 or 1 13, or 13 or 3 16. C10 8 16. So C option is correct. Question number 24. The compound cetyl palmitate C15H31 CO2 C16H33 is a waxy solid. This is an ester. Cetyl palmitate is heated under flux with an excess of aqueous sodium hydroxide. Which products will be formed? So this is alkaline hydrolysis. Let's check. C15 R C15 H31 CO2 C16 H33. So plus sodium hydroxide to form C15 H31 CO2 Na plus C16H33 OH. So this is alcohol and this is sodium salt. Which products will be formed? C15H31ONA is incorrect. C16H is also incorrect. C15H31 CO2Na, this is correct. This is incorrect. C15H31 it is incorrect. C16H33 CO2Na, this is also incorrect. C15H31 CO2Na is correct option, and C16H33 OH is also correct. D option is correct. When an organic compound is oxidized, any oxygen atom gained by the organic molecule is considered to be from a water molecule, also producing 2H positive, 2H positive plus 2 electron. Any hydrogen atom lost may be considered to be lost as H positive, and these changes can be represented by the following two equations: H2O, and this is loss of electron, and this is also loss of electron, oxidation. Now compound X is oxidized by heating under a flux with hot acidified potassium dichromate 6 for 1 hour. The half equation for the reduction reaction is shown: Cr2O7 2 minus plus 14H positive plus 6 electron. This is reduction reaction, and under this condition 1 mole of potassium dichromate oxidizes 3 moles of X. What could be X? Let's check. CH3, this is propanol, CH3, CH2, CHO. So oxygen, one oxygen atom to form CH3, CH2, COOH. One oxygen atom is added. So for one oxygen atom there are 2 electrons. Two electrons are two electrons are lost by this. So propan 1 all, this is propan 1 all, CH3, CH2, CH2OH, CH3, CH2, COOH. See, one oxygen atom is added, and loss of 2 hydrogen atom plus loss of 2 hydrogen atom. So for gaining of 1 oxygen atom there are 2 electrons, and for loss of 2 hydrogen atoms also 2 electrons. So total electrons are 4. So propan 1 2 diol, propan 1 2 CH3, propan 1 2 diol, CH3, CH2, CHOH. CHOH and CH2OH. So oxygen atom is oxidized. This is CH3 C double bond O and COOH. Loss of 4 hydrogen atom mean 4 electron. Four hydrogen atom mean 4 electron and gain of 1 oxygen atom. 1 oxygen is added and propane 313 diol CH3 CH2OH propane 13 CH2 CH2OH CH2 and CH2OH. So one is ketone, 2 carboxylic acid is formed because this is 1,3 diol. So this is HO, C double bond O, CH2, C double bond O and OH. Loss of 4 hydrogen atom and gain of 2 oxygen atom. 2 oxygen atom. Here 2 electron and over here 2 electron. So loss of 4 hydrogen mean 4 electron and 1 oxygen 2 electron, and loss of 4 hydrogen mean 4 electron, and over here 2 oxygen atom means 4 electron. So over here 4 and 2 6 electron, and in this case 8 electron. So this is 6 electron. So for 2 chromium atom, the 3 electrons are for each oxygen atom. If 2 Cr2, that 2 Cr, 1 Cr loses Cr3 plus electron, gains 3 electrons. So it is multiplied by 3. This is multiplied by 3. This is multiplied with 3. This is multiplied by 3. So this is equal to 6 electron. So this is equal to 12 electron. For this it is equal to 18, and this 24 electron. So 6 electron over here, 6 electrons are gained by this reduction reaction. So there must be 3 mole of propanol. So option A is correct option. Question number 26. Compound X has the empirical formula C2H4O. Its infrared spectrum is shown. So Compound X has the empirical formula C2H4O. Its infrared spectrum is shown. This is by looking in data booklet. This peak is H2C and H alkane, and this is 2850 and 2950. This peak is C double bond O, C double bond O, and this is present in 1670 to 1750. This is sharp peak, and this is CO peak is there. Now let's check what could be the skeletal formula of compound X. Skeletal formula of compound X, C2H4O. This is C2H4O compound. So this is CH3, CH2 and CH3. 3, 2, 5 or 3, 8. 1, 2, 3, 4. So this is C4H8O2, and empirical formula is C2H4O. So this is CH2, this is CH2, this is CH2C. 1, 2, 3, 4, C4, 2 or 2, 4 or 2, 6. C4H6O, 2. 2 1s are 2, 2 3s are 6, 2 2s are 4. The empirical formula is C2H3O. This is incorrect. So this is C, CH, CH and CH2. 1, 2, 3, 4, C4, 2, 3, 4, 5 and 6. C4H6O2, C4H6O2. So the again empirical formula is C2H3O. This is also incorrect. This is CH3, and this is CH3, and this is CH. 1, 2, 3 and 4. So this is C4H8O2, and this is C2H4O. So this is also same. A and D empirical and molecular formula will be same, but different groups are there. Now look at the peaks. This is CH2, CH3, CH2C. So this peak is present. This peak is present. CH2, CH3 and CH2. This peak is present. So this is CO. This is also present, and C double bond O. This peak is there, and this is again CH2, CH2H. So this is present. Now let's check with this. OH has broad peak. Let's use another color. For this, OH is different group which is not present over here. So OH peak is absent, which is present over here. Broad peak, so which is absent. So CO, C double bond O is present, but this peak is absent in this compound, and this peak is present. So the best option, this is incorrect, the best option is A. Question number 27. How many moles of hydrogen are evolved when an excess of sodium metal is added to 1 mole of citric acid? So this is citric acid. Over here H is removed, Na is added. Over here H is removed, Na is added. H is removed, CO2, Na and Na. There are 4 atoms of nitrogen, sodium, so it means 1, 2, 3 and 4. 4 hydrogen atoms are lost. So it means if 4 hydrogen atoms are there, there would be 2 moles of H2. So C option is correct. C option. Question number 28. Which statement is correct for reaction of carbonyl compounds with HCN? The reaction is carbonyl compounds with HCN. Let's check. CH3 reaction is catalyzed by concentrated sulfuric acid. The reaction is catalyzed by sulfuric acid. It is not catalyzed by sulfuric acid, concentrated sulfuric acid. So pentane 2 1 on and HCN react to give a chiral carbon. CH3 C double bond O, and this is CH2 CH2 CH3. This bond is broken down, partial negative, partial positive, and this is CN. In next step, C H3 C O CN CH2 CH2 and CH3. So HCN, partial negative, partial positive. So this double bond is over here, and the product is CH3 COH CN CH2 CH2 CH3. So the pentane 2 on and HCN reacts to give a chiral products. So this must be chiral carbon, because this carbon is surrounded by 4 different groups. So this option must be correct. The reaction is condensation reaction. It is not condensation reaction, it is nucleophilic nucleophilic addition. This is nucleophilic. This is also incorrect. Reaction is nucleophilic substitution. It is not substitution. It is nucleophilic addition. So this is also incorrect. B option is correct. The table describes 4 reactions of propene. Which row is correct? Propene, aqueous bromine, CH3, CH double bond CH2. So aqueous bromine to form CH3 CHBr and CH2Br. So this is incorrect. This is 2 bromo. This is 1 2 dibromopropane. So this is incorrect. Next, cold acidified aqueous potassium manganate propane 1,3-diol is formed. Cold aqueous potassium CH3 CH double bond CH2. Acidified aqueous potassium manganate 1,3-diol. So CH3 CHOH and this is CH2OH. So this is 1 2 propane 1,2-diol. This is propane 1,2-diol. So this is also incorrect. C is hydrogen chloride CH3 CH double bond CH2 plus HCl. So there are 2 products are formed. One is CH3 CH2 and CH2Cl. So another product is CH3 CHCl CH2 CH3. So this is major product according to Markov-Nikov rule and this is minor product. So this name is 2-chloropropane and this is 1-chloropropane. So major product is more significant, so this option is correct. C option is correct. Propane 1-ol. So propane 1-ol again, this is the same 2 products are formed with steam. Propane 1-ol and propane 2-ol plus HOH CH3 CH2 CH2 OH. This is propane 1-ol. This is minor product and this is CH3 CHOH. See, this is major, and this is propentanol. So this is also incorrect. Butanoic acid is prepared from 1-bromopropane. This synthesis requires a sequence of two reactions. Which compound is prepared in the first stage of the synthesis? 1-bromopropane, CH3, CH2 and CH2Br. This is 1-bromopropane, and the synthesis requires a sequence of two reactions. Sequence of which compound is prepared in the first stage of the synthesis. First stage of the butanoic acid is formed. In first stage CH3, CH2, because in butanoic acid there are 4 carbon and over here there are 3 carbons, so we must have 4 carbons, so we use HCN. NaCN or KCN over here in ethanolic medium. CH3, CH2, CH2, CN. So this is nucleophilic substitution. And this is again hydrolyzed to form HCl plus water to form CH3, CH2, CH2, COOH plus NH4Cl. So this is butanoic acid is formed from 1-bromopropane. The synthesis requires a sequence of two reactions. This is one reaction and this is second reaction. Which compound is present in the first stage? In first stage of the synthesis, 1-aminopropane. This is incorrect. Propane 1-ol is incorrect. Butanol is incorrect. So this is butane nitrile. D option is correct. Question number 31. Ethanol combines with ethanoic acid to form ethyl ethanoate according to the following reaction. 9.2 gram ethanol, 12 gram ethanoic acid and 8.8 gram ethyl ethanoate are mixed and allowed to stand at 298 Kelvin until equilibrium is reached. The resulting equilibrium mixture is found to contain 4.8 gram ethanoic acid. The experiment is repeated at 323 Kelvin. Which statements are correct? This is 9.2 gram, 12 gram and 8 are mixed and allowed to stand at 298 Kelvin. So this is C2H5OH plus CH3CO2H, CH3CO2, C2H5 plus water. So this is 9.2 divided by 9.2 divided by 46, we get 0.2. This is 12 divided by 60, this is again 0.2, and 8.8 divided by 80, this is equal to 0.1. So these moles are present, allowed to stand, and the resulting 8.8 gram moles ethyl ethanoate are mixed and allowed to stand at 298 Kelvin until equilibrium is reached. The resulting equilibrium mixture is found to contain 4.8 gram ethanoic acid. This experiment is repeated at which statements are correct? There are 0.22 moles of ethyl ethanoate in the mixture at the equilibrium. 0.22 moles until equilibrium is reached. Resulting mixture is 4.8 gram of ethanoic acid. This is 4.8 gram ethanoic acid. It means 4.8 divided by ethanoic acid 60. So it means 0.08 moles. 0.08 moles are present in equilibrium. If 0.08 moles, so what would be the change in moles? 0.2 minus 0.08, this is equal to 0.12. So this is 0.12, this is 1:1, so this is also 0.12, and this moles are, this is again 1 to 1. If 0.12 moles, 0.08 moles are there, so it comes 0.12, and these moles are added, so this is 1:1, 0.12 mole, or these moles are added at equilibrium. This will be 0.22 moles. So this is, there are 0.22 moles of ethyl ethanoate in the mixture at equilibrium at 298 Kelvin. So this is correct. The equilibrium mixture at 323 Kelvin will contain more than 4.8 gram of ethanoic acid. So this is 0.08 moles, which is equal to 4.8 gram of ethanoic acid. So this reaction is exothermic reaction. When we increase temperature, reaction will be reversed back and more carboxylic acid is formed. So this option is also correct, that equilibrium mixture at 323 Kelvin will contain more than 4.8 gram of ethanoic acid. So more reactants are formed because reaction equilibrium will be shifted to left hand side, and more than 4.8 gram of ethanoic acid. This is also correct. If small amount of water is added at the start of either experiment, the value of Kc would not be affected. Value of Kc is only affected by the temperature. So this is also correct statement, that small amount of water is added at the start of either experiment, the value of Kc would not be affected. This is also correct. So when three statements are correct, the option will be A. Question number 32. Question number 32. The diagram shows an incomplete energy profile diagram for reaction. So this is incomplete diagram. Just let's complete this diagram. This is endothermic energy profile diagram. Endothermic energy profile diagram. Which could this diagram refer to? Calcium carbonate to calcium. This is decomposition reaction, and decomposition is endothermic. This is correct. Hydrogen gas to form two hydrogen atoms, so this is also bond breaking. So bond breaking is endothermic, so this is also correct. Cl negative aqueous, Cl negative gas, aqueous ions changes into gaseous ion. This is again, this option is correct because Cl negative aqueous converted into Cl negative gas. So this is also correct because this is endothermic. Aqueous changes into gaseous form. Cl aqueous and this is gas, so this is also endothermic reaction. And option statement 3 is also correct. So if three options are correct, three statements are correct, the option will be A. A gaseous hydrocarbon has a density of 2.42 gram dm cube per decimeter cube under room conditions. What could be the skeletal formula of this hydrocarbon? This is 1, 2, 3, 4 C4H8 has a density of 2.48 gram. 2.48, this is equal to 12 4s are 48 plus 8 is equal to 58 gram per mole, and this is 58 and gram per dm cube. 1 mole is equal to 24 decimeter cube. So this is 58 divided by 24. This is equal to 2.42 gram per dm cube. So this is correct option. This is also 4C4H8. 48 plus 8 is equal to 50. This is 10, sorry. This is 10. And this is C4H8. This is 56 gram per mole, and 56 divided by 24 is equal to 2.33 gram per dm cube. And this is again C4H8 is equal to 48 plus 8 is equal to 56 gram per mole, and 56 divided by 24 is equal to 2.33 gram per dm cube, or gram dm inverse cube. So only this is incorrect, this is incorrect, only one option is correct, so the option is D. Only one statement is correct, the option will be which molecule contain at least one bond angle of 120? This is C2H4, C2H4, so this carbon is 120, this is again 120, this is trigonal planar, so this is also 120, the bond angle is 120, this is correct. PF5, this is P, F, F and F, and this is F and F. This is 120. If we see this fluorine atom P, this is 190, two angles are there, 90, and this P, this angle is 120. So 120, this is also correct option. NCl3, this is Cl, this is Cl, and this is Cl. So there is lone pair of electrons, so lone pair of electrons repel the bond pair, so bond angle decrease to 107, bond angle is decreased to 107 degree over here, so this option is incorrect. If 1 and 2 are correct, if 1 and 2 statements are correct, the option will be B. This is B. The option is B. Which statement are correct going across period 3 from sodium to chlorine? Sodium to chlorine. The charge on the nucleus increases, pulling the electrons closer to it. So this is correct because across the period nuclear charge increases and pulling atomic radius is going to decrease. So this is correct. The radius of the most common ion of each element decreases. Across the periods, you know that sodium positive ion, magnesium 2 positive, aluminum 3 positive. So charge of cation is decreases from its neutral atom, but across the period Cl negative, S negative 2 and phosphorus negative 3. So this is across the period, this is cations. The size of cation is smaller than the neutral atom, but the size of anion is greater than the neutral atom because electrons are gained in non-metals. So due to electron repulsion, the charge of anion is going to increase. So this is not decreases, this is increases. The shielding caused by inner electrons decreases, so the outer electrons are pulled closer to the nucleus. Because sodium to chlorine, it is in same period, so shielding caused by inner electron is not decreases, not increases. So shielding effect remain the same across the period, so this is also incorrect. So if one option is correct, if one statement is correct, the option is D. Question number 36. Which statement are correct? Magnesium carbonate decomposes at a lower temperature than calcium carbonate. Stability of metal compound is increases downward. This is group 2 compounds. So magnesium carbonate decomposes at lower temperature than the calcium carbonate. So because stability of compound is increases downward. So calcium carbonate require more energy to break down than magnesium carbonate. So this is correct option. Calcium hydroxide is more soluble in water than magnesium hydroxide. Solubility of hydroxide increases downward. Solubility of hydroxide is also increases hydroxide increases downward. So this is also correct. Calcium hydroxide is more soluble in water than magnesium hydroxide. Calcium is stronger reducing agent than the magnesium. So across the period, group 2 downward size of atom is increased. So when size of atom is increased, so it is more easier to remove electron from the outer shell. So that's why it more easier for lower element in group 2 to remove its valence shell electron. So that's why calcium is stronger reducing agent than the magnesium. So this is also correct. So if three statements are correct, the option will be A. 37. Which statement are correct? 1,1,2 difluoroethane is less reactive than 1,1,2 dichloroethane. This is 1,1,2 difluoroethane, and this is the same structure. Instead of chlorine, this chlorine CH3. So is less reactive than the 1,1,2 dichloroethane. CF bond is more stronger bond, more stable bond than the CCl bond. So that's why it is high. This bond CF bond require more energy to break than CCl bond. So it is correct. 1,1,2 difluoro is less reactive than the 1,1,2 dichloroethane. 1,1,2 difluoroethane is polar. So this is most electronegative element of the periodic table, carrying negative, but this is positive. So this is polar because two poles are present, negative and positive. So that's why this statement is also correct. The CF bond is stronger than the CCl bond. So in first statement it is 1,1 difluoro ethane is less reactive than 1,1 dichloroethane. So it means that the bonds are stronger and require more energy to break this bond. So that's why it is less reactive than 1,1,2 dichloroethane. So CF bond, it means CF bond is stronger, require more energy to break than the CCl bond. So this is also correct. If three statements are correct, the option will be A. Question number 38. Which pairs of compounds may be distinguished by testing with alkaline aqueous iodine? Butanol and butanone. CH3 CH2 CH2 CHO. double bond O and CH3, C double bond O, CH2 and CH3. This will not give the positive result with alkaline aqueous iodine, so it can give the positive test with the aqueous iodine. So as it is CH3, it is directly attached with C double bond O. So this gives yellow precipitate when react with alkaline aqueous iodine, CHI3 is formed. So this is giving the positive test, but this cannot give. So butanol may be distinguished by testing, so this will be distinguished with positive test. So this is correct option. Pentane 2 on and pentane 3 all. Pentane 2 on and pentane 3 all. CH3, C double bond O, CH2, CH2 and CH3. This also gives the positive test with iodine. Pentane 3 all, CH3, CH2, C double bond O, CH2, CH3, and this will not give the positive test with aqueous alkaline iodine. So this is incorrect. So this statement is correct because it can be distinguished between these two compounds. Propanone and propane 2 all. This is propanone, C double bond O, CH3, and propane 2 all, CH3, CHOH, CH3. So this will give the positive test with alkaline aqueous iodine. This will also give the positive test with aqueous iodine. So cannot distinguish between these two compounds because both will give yellow PPTs of CHI3. So this is incorrect. If 2, 1 and 2 are correct, so this is correct. Option is B. Which reactions have question number 39? Which reactions have colored organic product? Ethanol plus 2,4-dinitrophenyl hydrazine. It gives orange precipitate. This is the confirmatory test of ethanol carbonyl compounds with 2,4-dinitrophenyl hydrazine that gives orange precipitate. Ethanol plus acidified potassium dichromate. Ethanol is oxidized to form ethanoic acid, so this is colorless, purple to colorless product. Ethene plus cold dilute acidified potassium manganate. This is again CH2OH 2,1,2-diol is formed. So again the solution will become colorless. when ethene react with cold dilute acidified potassium manganate. So this is incorrect. This is incorrect. Only one statement is ethanol gives orange precipitate with 2,4-dinitrophenylhydrazine. So first statement is correct. If one statement is correct, the option is D. Next question is propanoic acid is reacted with an excess lithium aluminum hydride. The organic product of this reaction is reacted with ethanoic acid in the presence of concentrated sulfuric acid, forming product X. Propanoic acid CH3CH2 COOH when react with this is reducing agent AlHL4 to form propanoic acid reduces to propanol CH3CH2 CH2OH addition of hydrogen. So this is propanol is formed. The organic product of this reaction is reacted with CH3 CH2 CH2OH plus ethanoic acid CH3 COOH to form CH3 CO2 CH3 CH2 CH2 CH3. So propyl ethanoate is formed. So this is an ester. What are major commercial uses of X? It is not used as a fuel, it is used as a solvent and used as a flavoring. When 2 and 3 statements are correct, the option will be C. So if you like this video, please subscribe and share this channel and hit the bell icon for further notification.